My name is Dr. Helen Green and I'm a research fellow in rock art dating in the School of Geography, Earth and Atmospheric Sciences at the University of Melbourne. I'd like to begin by acknowledging the traditional owners of the land on which we meet today, so the peoples of the Kulin Nation, and the land on which I'm lucky enough to work in the Kimberley on Balangara country, and to pay my respects to elders past and present. In particular, I'd like to thank our friends and colleagues in the communities of Columbaroo and Wyndham, including my good friend Ian Wayner, who's pictured here on the first slide, and our research partners, Balangara Aboriginal Corporation. And tonight I'm going to be talking about the Kimberley Rock Art Dating Project. And this is an Australian Research Council linkage project led by Professor Andy Gladdow at the University of Melbourne, and partnered with many other universities and organisations around the country, with our biggest support coming from Rock Art Australia and Balangara AC. I've been lucky enough to work on the Kimberley Rock Art Dating Project since 2014, and we've been fortunate to receive 2 rounds of ARC funding in that time, with our current project set to end at the end of next year. The Rock Art Dating Project uses a wide range of scientific and archaeological techniques, and it's set out to better understand the landscape processes which impact Indigenous rock art found in the Kimberley, and then to apply a range of scientific techniques to date how old it is. And I'm going to talk about these techniques tonight. Since 2014, we've visited the Kimberley each year during the dry season, so in the middle of the year, to collect samples from rock art shelters. And actually making this slide made me a bit nostalgic or a bit sad, because I look significantly younger in that first picture than I do in the ones taken more recently. But it's actually been a really huge privilege to be involved in what has been a remarkable project, both in terms of the groundbreaking science, the breathtaking landscape, the remarkable people that have been involved over the last 8 years, and the astounding cultural heritage that we're all working to better understand and hopefully better protect as a result. So for those who don't know, Australia's Kimberley region is up here in northern Western Australia. You can see that white box around it on the left-hand side. And this has been the focus of our fieldwork over the last 8 years. Barking Owl Camp, which you can see located on that zoomed in map on the right, was the location of our first campsite back in 2015. And the research team have recently returned from the same spot just a couple of weeks ago. But between 2015 and 2022, we have had various base camp locations, depending on the area that we've been surveying. We've sort of hopped around on the banks of the Drysdale and King George rivers. But all of this work has been done within Balangara country, and this is the native title area that we work under and the group that we work with. And that's what's outlined on that map there in orange. And the reason we've focused our work in this area is that it's renowned for its rich Aboriginal heritage, and this includes thousands of rock art sites found in rock shelters which are scattered across the landscape. Importantly, Australian rock art is unique in that the ancestors of those who created these magnificent works of art are present on country, and we've worked closely with community members, rangers and traditional owners from the communities of Columbaroo and Wyndham whilst we've been in the field. And it's important for me to say here that every sample that's collected as a part of our research project and all of the work that's done in the field is done so with permission from a traditional owner who's present on site. And so our field camps are these huge operations. They often have 25+ participants from all over the world. And although there are many thousands of rock art sites in the region, they are quite difficult to find. They're located in one of the most remote areas of the world in a rough and rugged landscape. And so a lot of complex logistics goes into getting everyone safely out to sites each day whilst we're up in the field. We're lucky enough to have a fantastic camp manager, Paul Hartley, who's pictured here with the staff overlooking the camp as we're all eating our dinner, and a camp cook, Robin Mayer. We also have a camp pilot on site with us who looks after us and helps us work as efficiently as possible. We also benefit hugely from the survey work of many researchers who have worked for decades in the Kimberley, way before we got there, bashing through the bush to record the art and document its location. And it's through this documentation that we've been able to target sites for research. We can look them up in a database, we can decide whether we need to go there for different parts of the project, and then we can access those target sites using the helicopter. And so while this all might sound like a pretty good gig, and it really is, we actually have a lot of hard work to do. We have a dedicated survey team who are looking for new art sites and recording those into that database, whilst the scientists and archaeologists follow one step behind them to assess the sites for dating potential as we go. And so that's a bit about where we are and how we get our samples, which is probably the easiest bit of this whole project. But let's take a step back and see where the Kimberley rock art fits into global rock art. So rock art, as you know, is a global phenomenon. And this map shows rock art sites that were included in the 2021 UNESCO World Heritage List. You'll notice that the Kimberley is missing from that list quite glaringly. The sites that are located there in Australia relate to Kakadu and Uluru. And I hope that by the end of my talk, you'll agree that that's a real problem. Rock art's defined as human-made markings placed on natural surfaces. So it doesn't have to be paintings, it can be engravings or it can be stone arrangements. But it's all so important because it provides this clear and long-lasting evidence for the transmission of human conceptual thoughts and beliefs through art. And it's been described by some researchers as the oldest books in the world. As you can see on the left-hand side of the slide there, in every region, the rock art is different. Perhaps it shows the different animals from those areas or human figures in different ceremonial scenes. Some rock art consists of symbols, but there are also some similarities seen across the world, and we see hand stencils both here in Australia and across in Europe and Indonesia. And so researchers are often in search of the oldest rock art in the world. It's a title we're all a bit guilty of chasing. And it's a title which is currently held by Maltraviso Cave in northern Spain, where in 2018, this ladder-like figure that you can see in the top left there, that sort of square red figure, was dated to at least 64,000 years old. And this was particularly exciting because it opened the possibility that Neanderthals were Earth's first cave painters. Elsewhere in Sulawesi, the oldest hunting scene in the world was dated the following year to at least 44,000 years old. And in 2021, also in Sulawesi, this warty pig up on the top right was dated as the oldest depiction of an animal in rock art at least 45,500 years old. So you might notice a theme here that if people can't find the oldest art in the world, they come up with another oldest title. You can see that on those top two figures, there's this white mineral coating that's covering parts of the paintings. And that's what the scientists in those areas have dated. And we're going to come back to that in a little more detail a bit later on. But down in the bottom right corner, you'll see another image. And this relates to work done just last year by my colleague, Dr. Damien Finch, who led our research team in a study which identified this life-size kangaroo, which you will see more clearly if I do this. And this is on the ceiling of a rock shelter in the Kimberley. And we now know that this is the oldest in situ painted rock art in Australia. And we'll talk about how old it is a little later on. Interestingly, what you can see very clearly here is that there's a very clear similarity between the depictions in Indonesia and Australia. But currently, these painting styles are actually of very different ages. And we're going to talk about that shortly as well. So how do we date rock art? Well, in some areas of the world, the art can be directly dated using a technique called radiocarbon dating. You've probably heard of radiocarbon dating before. Radiocarbon dating is best used on living things, and it's a technique that involves looking at the ratio of two different types of carbon atoms in a once living organism to basically work out when it died. So of the two different types of carbon atom, one is stable, and we call that carbon-12, and one isn't, and we call the unstable atom carbon-14, and this is radioactive. We know that every living thing is made up of carbon. So plants grab carbon dioxide from the atmosphere, animals then eat the plants, we then eat the animals. And this means that once an animal or plant dies and stops taking in that carbon, the stable carbon-12 atoms stay put, they remain the same, but the radioactive carbon-14 atoms start to decay away. They're unstable, they don't want to be carbon-14, so they start to decay until they become stable. And what this means is that an organism that died yesterday would still have a very high level of carbon-14 atoms because none of them have decayed away yet, whereas one that died tens of thousands of years ago won't. And that sort of determines the limit of radiocarbon dating. It can go back reliably to about 55,000 years ago. And you can see a time bar at the top there that's giving you an idea of the time span of this technique. And keep an eye at the top there because I've used a time bar for each of the different methods that we use in this project. But once we've run out of carbon-14 or it's not a measurable quantity anymore, we can't use radiocarbon dating. We know that the half-life of carbon-14 is 5,730 years. And what this means is that every 5,730 years, about half of the carbon-14 atoms will decay into a different atom. So if we think about this in the case of rock art dating, if there's a tree or an animal and then it's burnt and it turns into charcoal, which is basically just a carbon residue, and that charcoal is then used to draw on a cave wall, such as this example of Chevet Cave in France. It's quite a famous example, you may have seen it before. By sampling the charcoal directly, by taking a piece of that charcoal and measuring the amount of carbon-14 left against the stable amounts of carbon-12, those two carbon atoms, we can work out when that tree died. And we're pretty confident that the time that the tree died is going to be quite close to when the painting was done. And so by sampling the charcoal from the art directly, the oldest painting in Chevet Cave has been radiocarbon dated to 36,500 years ago. The challenge that we faced with the rock art dating project was that rock art in the Kimberley is largely ochre based. So that's that nice sort of reddy brown, sometimes orangey yellow color that we see in most of the paintings. It's quite characteristic of Kimberley rock art. And so what you're looking at in the right-hand panel here is a panel of guion figures. And guion is the name for this particular style of art in the Kimberley. There's a range of different styles of art in the Kimberley, and this one is called guion. And it basically consists of mainly human figures, and they're usually in some sort of ceremonial dress. And so you can see they've got those long headdresses, and they've also got decorations in really fine detail coming off their arms and legs. But when we actually compare that to images taken in the Kimberley of ceremonial scenes, so this is from a book by David Welsh, and it's a picture taken of a ceremonial scene in 1929, the paintings become even more remarkable. We can see that there's a real comparison there between those fine paintings and what was happening in real life. And we're going to talk about the age of this style of the art in a few slides' time, so remember those images. And so ochre is a natural clay earth pigment, and it consists of a mixture of iron oxide minerals and varying amounts of clay and sand. Unfortunately, unlike charcoal, there's nothing in there that can be directly dated. It doesn't have carbon in it, doesn't have anything that we can directly date. So instead, what we've had to do with this project is look for what we call rock art associated materials. So not the art itself, but things that might be associated with the art that can be dated. And so rock art associated materials are materials that are either underneath or over the top of the art, and they allow us to say whether the art is relatively older or younger than the dated material. And there are several what we call radiometric dating techniques that we can use on different rock art associated materials in different settings. And so radiometric dating is a method of dating something based on the presence of a radioactive isotope within it. And we've already talked about this a little bit with radiocarbon dating. So radioactive isotopes are unstable and they're trying to become stable. And they're doing this by giving off radiation. And in doing so, they decay or turn into other isotopes and elements until they're stable. The time it takes for this to happen is called the half-life. And the half-life is just how long it takes for a quantity to fall to half its original value. So if there are 100 radioactive isotopes at the beginning, there's only 50 after one half-life, 25 after two half-lives, and so on. Because we know the half-lives of isotopes on Earth, we can use these to work out how old something is. So we know for radiocarbon, the half-life is 5,730 years. We can measure the amount of radioactive isotope left in a sample relative to a known quantity, such as a stable isotope, and then we can work out an age. So we can use it a bit like, you can think of it a little bit like an hourglass, what's left at the top and what's accumulated at the bottom. So at the beginning of the project, Andy Gladot put together a team of people with a huge range of expertise in applying these techniques, though for most of us, it was the first time we'd ever applied them in the context of dating rock art. The 4 methods that are used in our research project in the Kimberley are listed here alongside the time periods that they can be used for. And so having multiple techniques is particularly useful in rock art research and particularly useful in Kimberley rock art research because it gives us more options. It widens the scope of whether it's possible to date the rock art based on the materials available at any given site. You can also see that the different techniques cover different time spans. So where radiocarbon dating might only reliably stretch back to 55,000 years ago, other techniques might push that out a bit further. And finally, it gives us an opportunity to cross-check the results of one method against another, which is really valuable, particularly when the work is quite pioneering. So let's start from the beginning and we'll go over this technique by technique so that you can understand how those methods are applied in the context of dating the Kimberley rock art. So the ultimate upper limit on the age of rock art is the age of the surface it was painted on. The art can't be older than the surface that it occurs on. However, in the Kimberley, the majority of rock art is found painted on a type of rock known as sandstone. And these Kimberley sandstones, so the Wharton and the Woonamin Millawundi, which are the names of the sandstone formations in the Kimberley, are over 1 billion years old. So it doesn't really help us much. It doesn't provide us with much of a constraint. But Kimberley rock art is found in what we call shelters. So these 2 images here are quite classic Kimberley rock art shelters. They have the sandstone formations that have walls, ceilings, and floors. And actually the one on the right-hand side here, if you remember that kangaroo that we saw at the beginning of the presentation, that's where that kangaroo is from. It's on that ceiling in that narrow little gap there. And that's the location of the oldest rock art in Australia. And they're often very pleasant places to sit and presumably to paint, or in our case, to admire the paintings and to sample, because they're sheltered from the heat or from the rain, depending on the season. So apologies for the image on the right. I will get to that in a few minutes as to why that's relevant. Our research team set out to understand more about the life cycle of these shelters and how they form. How long do they last for before they collapse? How long do they hang around for? And that provides the ultimate control on the survival of the rock art. And what they found is that although these shelters are transitory features of the landscape, so when we were there just a couple of weeks ago, we saw that a slab had fallen, a really big slab from one of those shelters had fallen since we were last there a couple of years ago. So it was quite scary, but these shelters are cycling through and they are collapsing on the timescales that, we've been in the Kimberley. But the shelter forming process rates are so low that the rock surfaces and the rock art on them may survive for tens of thousands of years. There is the capability for these shelters to survive on the timescales that we are looking at to date the art. And to determine this, the team used a dating technique known as cosmogenic nuclide dating, or just cosmo dating for short. And this is a technique that can be used to date the uncovering of a surface. So for example, if a rock was covered by ice during a glaciation and then that ice has melted away, we can date when that rock was exposed from the ice using this technique. And that's because this technique is based on the continuous bombardment of Earth with very high energy cosmic rays. And these cosmic rays originate from the explosions of a supernova out in space. But only a very tiny proportion of these rays actually reach the Earth's surface. About 0.1% of the rays reach the Earth's surface with enough energy to cause nuclear reactions in the rocks that they hit. And when certain elements in those rocks are hit by a cosmic ray, they basically explode into even smaller particles, and that's called spallation. And most of those smaller particles either disappear very quickly because they're very short-lived, or they're already very common in Earth's crust, so you wouldn't be able to easily find them. But some are very rare, and some do stick around for long enough that they can accumulate in the rocks. And so by measuring these very rare particles and how much they have accumulated, we can basically calculate how long the rock has been exposed for, a bit like measuring how long a person has been exposed to sunlight by measuring the tan on their skin. We've got around to there eventually. So if we think about that in terms of rock art dating, here's our rock art shelter in the middle of this slide. And above it, those cosmic rays are constantly bombarding the earth. They're hitting these rocks. But that slab that's labeled shielded there underneath the shelter is protected from those cosmic rays because they don't penetrate very deeply into the Earth's surface, only the upper few most meters. So it's shielded, and that is until it falls and becomes exposed, and we call this a slab fall. Once exposed, the absorption of the cosmic rays generates those very rare particles, or what we call cosmogenic isotopes, and they accumulate in the rock at a known rate. And so we can then measure these particles to tell us how long that slab has been exposed for. If there's an art that's been painted on that ceiling or on that back wall from where the slab has fallen, we know that the art must be younger than the fall. And so this gives us a minimum age constraint on the art that's in that shelter. It's a particularly challenging sampling process. You can see PhD student Gail Kazes, who's done a lot of this work, is abseiling down the side of a shelter. He had to collect samples from the top of the shelter as well as those within the shelter. And so it's a challenging technique, but it does provide us with some constraint on the ages of the art. If we look at a real example here, we've got a pair of samples, one from the ceiling and one from that slab fall. And these have given an age of around 10,000 years. So we know that that slab fell down there just past Damien around 10,000 years ago. There are then paintings, very faded paintings on that ceiling and back wall from where the slab fell. So we know that this art must be younger than the slab fall. It must be younger than 10,000 years ago. Interestingly, in this example, there's also an art panel up the top there, high above one end of that fallen slab. And it appeared to us that that must have been painted by standing on that slab as it projected out from the rest of the rocks before it fell. And so that would mean that the art up at the top would need to be older than the slab fall, so older than 10,000 years old. And so cosmodating gives us a first order understanding of the age of any art that's in the shelters, but not all shelters demonstrate clear slab falls in association with rock art. Sometimes there isn't a slab fall. Sometimes the slab has shattered into many, many pieces that are difficult to find and put back together. Or sometimes the dates just might not work. The age brackets that they provide might be quite broad and not provide us with any particular constraint for the art that's there. And so that meant that we needed other rock art associated materials, and we needed to use other techniques. So another rock art associated material is a mineral coating. And mineral coatings form on rock shelter surfaces. And if we're lucky, those coated surfaces have been painted over, or the coatings have formed on top of the pigment. And we can use a method known as uranium-thorium dating, and this is another radiometric dating technique to date these materials. So how this works is that the element uranium is soluble in water, and so all natural water contains a very low trace amount of uranium. It's not dangerous, it's just picked up from the surrounding environment in trace levels. But importantly for this dating technique, it contains none of the element thorium. Thorium is completely insoluble in water. So inside caves or on the walls of the rock shelters in the Kimberley, rainwater that's carrying that uranium washes down over the rock surfaces. And as that water dries, the minerals form from these waters and trap that uranium in the structure. So the water evaporates and minerals are deposited and they contain that uranium. That uranium then radioactively decays to another element called thorium. And because we know how long that decay takes, if we measure the amount of uranium that's left in the sample and the amount of thorium that's accumulated in each of those layers, we can work out how long ago the mineral was deposited or how old it is. And so again, you can think of this a bit like an hourglass with uranium left at the top and thorium accumulating at the bottom. And so in the context of dating rock art, if in between the deposition of those layers, somebody has come along and painted on this nice fresh mineral surface, we could take a sample of this coating and we'd expect to find that ages 1 and 2 are older than the pigment, whilst age 3 would be younger than the pigment. And this would provide a nice bracket around when this painting was done. And so this technique has been applied to mineral coatings associated with rock art pigment in several different settings. In fact, the last 3 oldest ages in the world for rock art in Spain and Sulawesi were uranium thorium dates on mineral coatings. And that's what you're looking at here. This isn't the Kimberley, this is Spain. And that's an example of a very tiny, you can see the scale down the bottom of a centimetre there, a very tiny mineral coating that's overlying pigment in a cave in Spain. And it was used to identify this figure as the oldest rock art in the world. You'll remember that I mentioned that sort of ladder-like figure on the first slide. And because those researchers dated that mineral accretion to 64,000 years ago and the art was underneath it, they could then say that that art must be older than 64,000 years old. The situation in the Kimberley is a little bit different. We do have mineral coatings, just like the one that you can see obscuring this panel of Guion figures here. So this is that style of art in the Kimberley that we've already seen today, which is focused on human figures with those headdresses and the decorations. It's just quite obscured by that mineral accretion. And so this painted panel has a mineral accretion, which is apparently forming over the top of the painting. But this is one of the complications with using mineral accretions. When we took that sample, so you can see it's on the headdress there, there's a little feather coming off the headdress, and the edge of that mineral accretion is just going over that feather, or so it seems. But when we took that back to the lab, we could see that pigment is actually encapsulated between different layers above and below the sample, above and below the pigment. And this would provide opportunities to bracket the age of this painting. The problem is that the uranium thorium dating technique has been developed over many decades for a particular mineral type known as calcite. And calcite develops from waters in limestone regions, and it's what makes up stalagmites and stalactites that we find in limestone caves. In Europe and Indonesia, the caves where rock art are found are formed in limestone environments, and the accretions forming over the paintings are made of calcite, as I've mentioned. But Kimberley rock art is found in these sandstone shelters. And this means that the accretions are made of very different materials which have never been dated before using uranium thorium methods. Also, unlike the art sites in Europe and Indonesia, we're not working in these pristine underground caves where the art and the accretions are protected from any dirt or dust. As you can see from this image, the art is located in open shelters, and these shelters are exposed to the wind and the rain that can bring dirt into the shelters. And unfortunately, dirt contains thorium. We said that the thorium is not soluble, it's not in the water, but it is in dirt and dust. And so this can complicate our age equations. It can make samples look much older than they really are by basically adding extra sand to the bottom of that hourglass. And so unless we very carefully correct the samples for this detrital or dirty thorium, they can throw our ages off quite significantly. And so the application of uranium thorium to Kimberley accretions is still a work in progress, and we're developing a method to enable the application to these new materials. We can use laser ablation trace element mapping with a mass spectrometer to produce these heat maps that you can see down the bottom here. So what you're looking at is an accretion. You can see the layers that have built up over time. That's only about a centimetre thick. And we fired a laser at that material, and the laser ablates the accretion, so it vaporizes it, and then the material that's vaporized is sucked into the mass spectrometer, and the mass spectrometer measures what is at every single point that the laser's fired at. So those lines that you can see in that top image of the accretion are where the laser has fired up and down in parallel lines to produce those maps. And the maps are like heat maps. They're telling us where particular elements are focused. So in this case, the yellow areas are demonstrating where there's high detrital thorium. So we know then that we can avoid those areas when we're trying to do the dating. So we use the maps to then inform our microsampling for the dating, and we also do this with a laser. So those spots that you can see on that image at the top as well are also laser spots where the laser has ablated material, but this time it's sucked it in to measure the sample for dating. And by doing that, we're able to avoid areas that are particularly problematic and contain uranium, but high amounts of dirty thorium. So we don't want to measure that. And so this is, as I say, this is a work in progress. We've still got a little bit to do here. And we hope that we can do this by reducing our errors and creating ages that are usable. At the moment, we are getting ages, but the error margins on those ages are so large that it's not actually telling us very much about the age of the rock art. The silver lining to this is that whilst investigating the Kimberley mineral coatings for dating and adapting that uranium thorium technique for application to these non-calcite, very dirty minerals, we've made some very interesting discoveries. So the appearance of mineral coatings across the Kimberley varied from site to site and also varied in different areas of the shelter. And we spent the first couple of years of the project trying to understand what these mineral coatings were and how they differed from place to place. Coatings on the walls and the ceilings were distinct from those on the low angle surfaces in the shelter. And this is dependent on where the water had come from and what it had picked up along the way. In many sites across the region, we found this very distinctive, dark coloured, shiny and smooth glaze-like coating. We actually just call them glazes now, that were forming on these low angle shelter surfaces. And this coating appeared to have been an attractive canvas for the engraved art styles in the Kimberley. In fact, we didn't find any engraved art etched into anything but this mineral coating. So more commonly, these engravings occurred as these straight grooves. So you can see examples of this on the left-hand side of the slide there. So there's a darker mineral coating down the bottom and a sort of brownish coloured one at the top. And you can see those grooves have been etched with some great effort, I might add, because it's a really hard rock. It would have taken a long time to do that. And occasionally they cover these vast expanses within the shelters. So you can see on that bottom image, there's a scale bar just near the top there. And so that's covering a good couple of meters, and there's, you know, hundreds of engravings on there. Ground hollows, known as cupules, and you can see those on the right-hand side of the slide up towards the top, were also identified at several sites. And in some instances, we also found examples of engraved shallow motifs. So you can see those down the bottom there. And they're commonly of animal tracks or little birds' feet that have been scratched into this distinctive coating. Importantly, we've also identified rare examples of this same mineral deposit occurring in these crevices or on the ledges, which demonstrate a relationship to the painted art style. So again, this is a Guyon figure here. You can see the headdress up the top half and a sort of arm holding a decoration and the body on the bottom half. And you can see that this Guyon figure has been split in half when the slab has started to fall down. And then a deposit has formed, one of these glaze-like deposits has formed within that crevice. And so if we can get a date on that accretion, we know that the art has to be older because the art was there first. And so this striking link between these coatings and the engraved art that we find in the Kimberley opened potential opportunities to provide some age constraint. But the first thing we had to do was determine if the glazes contained anything that we could reliably date. So for the first few years of the project, we characterized these coatings using a range of different geological analytical techniques. And we found that whilst they still contain no calcite, there was no calcite in these deposits, they did contain a mineral called oxalate in significant proportions. So what you're looking at here are the X-ray diffraction data from the sample set, and you can see the different types of minerals in that pie chart. So you can see there's no calcite, there is some phosphates, some sulfates, and then a large proportion of oxalates. We sampled 75 of these glazes from across the region, and we identified this oxalate mineral in all of the samples. And within 77% of the samples, we found oxalate to be more than 50% of the composition. So it was there in high quantities. And this was really important because oxalate contains carbon in its structure. So this is a microscope image, and you can see those little blocky structures there are the oxalate crystals. And then down the bottom here, you can see that that's the formula for calcium oxalate, and that it has carbon in its structure, meaning that we could radiocarbon date them to provide any age constraints for any associated art. The other important feature of these coatings was that they demonstrated very clear layering when we looked at them in cross-section. And this suggested that they've built up progressively over time and allowed us to attempt to sample those individual layers separately. So you can see there that we're looking at it under the microscope. We've taken the sample back to the lab, cut it in half, and then we're looking at those layers. And down the very bottom of the right-hand side of the slide, what you're looking at is a field microscope image. So over the last 8 years, we've got some new kit, and we now have a microscope that we can take into the field. And you can actually see the layers in situ. You don't even have to take a sample to be able to see them. But we did take a sample of this particular glaze deposit. And when we looked at it under the lab microscope, we could also see those same layers occurring quite clearly. And so by using a tiny, tiny computer program drill, we were able to remove subsamples from individual layers within those coatings. And excitingly, what we found was that not only did the dates occur in sequence, so they got older towards the bottom of the sample, as you'd expect, and this proved the reliability of applying radiocarbon dating to these materials. But across the sample set, patterns observed in that layering of the samples collected at sites up to 90 kilometers apart were dated to be the same age. So what you're looking at here is a schematic drawing of 9 different samples. The sample names are along the bottom. And then we've had a look at them under the microscope, and we've made a little cartoon basically out of their layers. And we found there was these repeating layer patterns in samples that were collected from sites really far apart. And you can see where they were collected on that map on the left-hand side of the screen. When we then milled the layers that we'd matched up visually and put them through radiocarbon dating, we identified that the layers were the same age. And so what this suggests is that there's a regional scale control on the formation of these coatings. They aren't forming randomly. And we think that this is likely to relate to past environmental conditions in the region. Perhaps those layers only form when it's wet or warm, or perhaps they only form when it's cold and dry. But these coatings hold the potential to behave as a paleoclimate archive for the Kimberley, similar to tree rings or ice cores or sediment cores that are used elsewhere in the world. And as you can see from the dates on those different layers, which go back to 40,000 years ago, they're forming on timeframes which are comparable to the dates that we expect to emerge for different art styles, and at a time that we know the Kimberley was experiencing significant environmental change. So potentially providing insight into the conditions experienced by Australia's first artists when they were doing these paintings. And we'll come back to why this is important in a couple of slides' time.
Helen?
Yes.
Do you have any idea what sort of tool they use to make those carvings into the rock, and were any of the tools left behind? And this is the question from Hamster Pathalakath.
I don't, and it's probably it's not really my area, but we do have a team of archaeologists who we work with on a separate project which is partnered with us, and they have done a lot of work into the stone tools in the area. I don't know that they've ever found any directly associated with an engraving site, but that's certainly something that they're looking into. It's also not clear whether the engravings are symbolic when they're those sort of very parallel lines, or whether they are use wear, you know, sharpening of tools, or it sort of seems to vary from site to site. Where we see those vast expanses covered in those parallel grooves, I would say that that to me looks symbolic. But what I would say is that whatever tool was used would have had to have been pretty hard. Like, it's a pretty hard surface, and it would have taken a lot of effort to do the engravings. And so, you know, somebody really wanted to record, well, they either really wanted to sharpen their tool, or they really wanted to produce a symbolic surface. And so, you know, this technique is also not only the paleoclimate work was sort of a bonus and a really unexpected result of looking at these accretions, but it was also an important advance in the dating work, because suddenly it allowed us to provide age constraints for some of the engravings etched into the material. So depending on whether the groove has been etched into the glaze, it would give us a maximum age, or if the groove has been infilled with the accretion, it would give us a minimum age. And it also allowed us to provide minimum ages for paintings where we found the accretion to be related to them. And so in this instance, in this example that we saw a couple of slides ago, we dated the accretion that had formed in this crevice. It wasn't very old. It was only, you know, just shy of 2,000 years old, but it does give us open that possibility that where we find these accretions forming with a relationship to the painted art, they could provide us with some age constraint. The final technique I'm going to talk about this evening is optically stimulated luminescence dating, or OSL dating for short. And this technique is basically used to work out how long ago a grain of sand or a grain of mud was last exposed to sunlight. So simply you can think of this a bit like a battery. If a grain of sand is buried in the dark, it starts to accumulate electrons or charge. And this is just a result of the radiation that's in the rocks around it. Once it's exposed to sunlight, these electrons are evicted from the crystal and the charge drains to zero. In the context of rock art dating, if an animal or an insect digs up some of that sand, so the example here is a mud wasp who, they use the mud from the surrounding environment to create their nests. The charge in the grain of sand drains to zero as it's exposed to sunlight. So when the wasp digs up the mud and then it flies to wherever it's going to build its nest, the grain of sand drains to zero. When the grain is then buried deep in the nest and away from the light again, that charge starts to build up. And because we know how long this takes, we can work out when that grain was last exposed to the sun. If the nest is built over rock art, we know the painting must be older than the time the nest was built or the time that sand grain was reset. And so again, here's an example from the Kimberleys. This is quite a faded panel, but what you're looking at on the right-hand side there is a panel of little bats. So their heads are down at the bottom. Their sort of oval shaped bodies are in the middle and their little feet are hanging onto that crevice in the rock at the top there. And on the right hand side, you can see that there's these big old nests which have been built over the top of the paintings. And that would suggest that the paintings has to be older than the age of the nests. And the preliminary results for those nests are around 12 to 13,000 years old. So we know those little bats must be older than that age. The challenge with OSL dating is that nests must be collected from the shelter walls at night because the grains can't be exposed to the sunlight. So we've done a lot of, the team have done a lot of camping out at the sites overnight and sampling with a red light to avoid exposing those grains to the sun or to any kind of white light. And then they're analysed in the laboratory under darkroom conditions. So this is Professor Bert Roberts from the University of Wollongong, who is leading that area of the research, and he's collecting samples at night time. The other challenge is that they have to be quite big nests. So those sand grains have to be protected from the sun whilst they're sitting out on the shelter walls. And to do that, they have to be quite large. So they have to have survived on the walls of the rock shelter, exposed to the monsoon and the wind and the rain for tens of thousands of years. And so those are quite difficult to find and they're few and far between. But wasp nests are particularly useful for rock art dating because they can also be dated using the radiocarbon method. And if we go back to this guy, this Guion figure that we've seen a couple of times this evening, we can see that the decoration on his right shoulder is covered by what we call a wasp nest stump. And that's this little thing here. And here's Damien and I collecting that very sample back in 2015 at a site overlooking the Drysdale River. But you might be thinking it doesn't look much like a wasp nest, and how does Damien radiocarbon date this sort of material? So if we imagine we're about 16,000 years in the past and a mud wasp builds a nest on the wall over the top of the painting, the nest would have looked a bit like this one on the left-hand side here. It's much bigger than the nest that's left behind 16,000 years later, and it potentially covered much more of that painting than it does today. That nest there would be about fist size. And this is what we call a modern nest. It was built in 2017 and collected by Damien during our wet season field trip of that year, much to the dismay of the poor wasp who'd built it. But nests that were built 16,000 years ago were also likely to look just like this. If we then flip that nest around, it looks a bit like this. So the wasp collects mud from the surrounding region and it uses that to build what we call cells. And cells are those oval shaped holes in the nest that you can see there. In the central cells, the wasp lays its eggs, and you can see the baby wasps just there. And in those outer two cells, the wasp fills this with either paralyzed spiders or paralyzed caterpillars that can be used as food for those baby wasps once they hatch. If we fast forward to today, on the right-hand side of the screen in that red box there, you can see how these are those same cell walls that we see in a modern nest, but after 16,000 years or so of weathering, you can just see those sort of faint outlines of that oval shape And that's how the two things relate to one another. And so basically that is what's left behind, these little nest stumps that retain that oval cell shape. And we call this a fossilized nest. And we know through Damien's work now that those nests can survive on the walls of rock shelters in the Kimberley for tens of thousands of years, which is pretty remarkable in itself, really. And there are various sources of carbon in wasp nests. And if we look at them under the microscope, we can see that the modern nest is made up of sand with some small black specks of charcoal and some bits of plant and insect exoskeletons. But it's really only the charcoal that survives on the timescales that we're working with. And it's this material in the nest stumps that Damien's dated. And on this particular panel, it's actually this nest that was on the shoulder there that's been radiocarbon dated. So this nest just here. And as the nest was over the art, it provided a minimum median age of 16,620 years for that particular painting. And so we know that the painting must be older than that age. However, this is actually a bit of an outlier in a much larger sample set, which was published in Science Advances in 2020. And in this study, 24 mud wasp nests were collected either over the top or underneath 21 paintings of this style. So these human figures with these decorations and headdresses. And those samples were collected from sites up to 100 kilometers apart. So here are some examples of those Guion figures and their associated nests and the associated dates. And by compiling all of that information together, Damien was able to conclude that the Guion art style was produced in a relatively narrow period. It proliferated at around 12,000 years ago. And so by using the field observations and the work of many researchers and rock art enthusiasts who have come before us, the rock art in the Kimberley can be split into these different groups or different styles based on which paintings or engravings look to be similar. They might be similar colors or they might show similar things. And we've given these styles names. These aren't their Indigenous names. They're just the names that we use to help us group them when we're working in the field and when we're sampling. And often we see panels like this one on the left-hand side here, where these multiple styles have been painted on top of each other over time. And by looking at those detailed panels very, very carefully, a relative sequence has been proposed, and we can hypothesize which appear to be the oldest styles and which appear to be the youngest styles. And so using this sequence, the Wandjina paintings, which you may have heard of, are the youngest in the sequence, and they relate to culture today. And those are those images down at the very bottom of that sequence there, those big sort of spiritual figures with big headdresses. And the irregular infill animal style, so that's that big kangaroo painting that we saw at the beginning of the presentation, both on the opening slide and the kangaroo that's been dated as the oldest in Australia. They're usually seen at the bottom of any sequence of paintings. And so that suggests to us that they must be the oldest painted art style. And so through this radiocarbon dating work that Damien's done, we now know where the Guion style fits into this larger sequence, somewhere in the middle at around 12,000 years ago. But what about the kangaroo? Well, as a result of the rock art dating project, we now know this kangaroo to be the oldest known in situ painted art in Australia. And the reason that painting looks particularly faded or unclear is that it seems to have been a favourite spot for wasps to build their nests thousands of years ago. You'll remember the image of the shelter that painting was in. It was quite sort of narrow and dark, and obviously somewhere where wasps like to be. And so much to Damien's delight, it was absolutely covered in hundreds and hundreds of fossilised mud wasp nests. And so Damien carefully sampled 3 nests that were over the painting and 3 nests that were under the painting. And the age of the oldest over art nest suggested that the kangaroo is older than around 17,200 years. And the age of the youngest under art nest suggests that it's younger than around 17,500 years. And so this means that we can give this motif, this kangaroo, a median age value of 17,300 years old, making it Australia's oldest art. And it's located here on the Drysdale River on Balangara country, as we know. And the reason we keep using that term in situ is because there has been other evidence of older rock art dated elsewhere. So a buried rock with 2 intersecting black lines was found here in West Arnhem Land in the Northern Territory. And it was found during an archaeological dig, and it was indirectly radiocarbon dated using ash that was stuck to the rock surface, as well as its position in that dig, to 28,000 years old. Back in the Kimberley, a similar situation where a painted slab was dated to 40,000 years old by O'Connor et al. In 2001. And so both of these findings suggest that it's highly unlikely that the kangaroo painting is the oldest surviving painting. It's just the oldest one that we've dated so far. And future research will also almost certainly locate even older works. In fact, I think that's something that's in the pipeline at the moment. But for now, the kangaroo is the oldest. And so we now know where this art fits into the larger sequence as well, and how it relates to what was happening in the Kimberley at this time. We can see that the art seems to change during that sequence. The things that people like to paint change over time. You can see that people are changing what they're wearing and what they're doing. And so, as well as dating the art, we're interested in why this is. Can it tell us things about climate change and sea level and how this affected life in the Kimberley? Can it tell us about how people lived and what they cared about and how they related to the landscape? We now know that there are two art styles, the irregular infill animal period, so the kangaroo, and the guion, so those human figures, and where they fit with large-scale climatic environmental changes like the last ice age, which was around 21,000 years ago, and the rapid sea level rises and the switch on of the monsoon, which was around 14,000 years ago. And so this is an active scientific investigation, and although the findings so far are hugely exciting, many, many more dates are required to help us better understand when each art period began and ended, and how Kimberley rock art fits into rock art dated across the world. And so our project ends next year, and yet we feel like we've only really just scratched the surface with this work. And that's not surprising given the sheer volume of rock art sites in the Kimberley and the length of time that we've been working there. We know that there's a huge disparity between the human occupation of Australia, which was dated to 65,000 years ago back in 2017, and the oldest art sites that we've dated so far. And we're not really sure why this is. We're quite sure that older paintings will be found. They might be closer to the coast, where people would have lived when the sea levels were much lower at the time of the last glacial maximum. So we know there are up to 106 meters lower at the time the kangaroo was painted. And that's what you're looking at in this illustration here. It's showing the sea level in the Kimberley back when that kangaroo was painted, and then again back when the guion figure was painted, or the guion figures were painted. And you can see that the landmass was hugely extended by the sea levels at those times. Those paintings are also likely to be hard to find. They're going to be faded panels covered in nests and accretions. They're probably going to be in some protected area that's not very easy to find. And so there's going to be a lot of work to do to find older paintings. Damien has revolutionized rock art dating with the application of radiocarbon dating to wasp nests, and we're hopeful that the other techniques will do the same with time, and we'll be able to cross-check those results using a variety of different methods. It's my hope that the work to understand those glaze-like deposits and their ability to record paleoclimatic change might support this work in helping us understand why the art styles might have changed and how people related to and recorded the changes that they were experiencing in their environment. And so we need more time, we need more funding, and we need more interest from all Australians to understand this precious cultural heritage that we should all be proud of, so that we can champion its recognition and its protection and conservation at all costs, especially in the face of increasing threats. And there's a shameless plug here on the bottom right of the slide for the Rock Art Australia website, where you can find out more about the research that the Foundation supports. But for now, I feel very honoured to have been involved with this team, working with remarkable people in a remarkable environment. It's often described as a once-in-a-lifetime experience, and I've been lucky enough to experience it for 8 years. So thank you very much for listening. I hope to answer any questions.
That was just absolutely magnificent. And when you said that we're just beginning to scratch the surface, I felt something in common with the Aboriginal artists. I also was reminded of a talk from Jim Bowler, who was talking about Mungo Man. And he said that amongst the remains, there was also traces of ochre of different colors, suggesting that ochre is used for ceremonial purposes, many thousands of years ago, not just for artwork. But it all ties into this remarkable picture.
Yeah.
So I'll have a look at the chat function and see if there are some questions coming along, while people are looking, here we come. Oh, mainly congratulations. Fantastic talk and wonderfully presented. Really interesting talk. Thank you. So how much longer do you think you'll be associated with this project?
Oh, well, I hope for a lot longer. My position is funded by Rock Art Australia through the Ian Potter Foundation. It currently runs until mid-2024. So there's certainly some time to do some more work and to get some more results that we can hopefully feed into an application for more funding. But like I say, there's so much more for us to do. And the other thing that's remarkable about this project, as well as the science, is the relationship that we've built with the communities in the Kimberley. This takes a long time, and we're very fortunate with the support that we've had from Rock Art Australia, that we've been able to work there for 8 years continuously. We had, a little bit of a gap during COVID, but we stayed in touch because it's important for this sort of work that you do turn up. You're not just a scientist who comes in and then leaves with your results and never shows up again. We go back every year. And we've made really strong friendships in those communities, and the guys that we work with from Columbaroo, who come out on the camp with us to help us with the sampling and help us with the research, are just fantastic. And we were there a couple of weeks ago, and the vibe on the camp, for want of a better word, is so positive. Everybody's so happy to be there, and everybody's so happy to work together. And so even just from that perspective, to continue this research and to continue that working relationship with those groups is really important, and I hope that we can do that.
Yeah, it's a beautiful story that involves art to science, and everything in between. There's a comment saying that Wikipedia makes mention of rock art in the Tibetan plateau dated to 160,000 and 230,000 years ago. Do you have any opinion on that?
I've never heard of that. The fact that it's on Wikipedia might tell us a little bit, unless it's reference to a peer-reviewed journal. But I can't imagine that that's true. I can't imagine what technique they would have used or how they would have done that. But yeah, I don't know anything about it, so I will go away and have a look. But it sounds quite unlikely.
Yeah. Okay. All right. Well, let's wrap it up there, and I'll just take this opportunity, first of all, to thank you for an absolutely magnificent, wonderful, entertaining and informative talk.